breaking all the specs, relativity theories. Worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Where's my music? Okay, I guess that's kind of decent music. Okay, cool. Let me get the YouTube working. What's up, Sensation?
Way I, man.
Scratch,
How's it going?
scratch. How is it going, dude? It's another day in paradise, you know? I woke up from a nap. I was tired. I did leg day today at the gym, so that's like really exhausting for me.
Every day is arm day, Professor.
Every day is arm day. I would say every day is back day, dude, when I'm the fucking carry, man. Now, leg day is always, like, pretty tiring because I think legs, like, by muscle group is the highest percentage volume or whatever mass of your body, right? Seems right, yeah?
Yes.
Yes.
There's the quadriceps and the gluteus maximus.
Right. Cheeks, thighs, and then you also got like calves and stuff. I didn't really work out calves today. I just did a bunch of squats. It's actually a decent question. Actually, I'm gonna ask. Let's ask ChatGPT. What
Of all
percent...
the things, sorry.
No, go on.
Of all the things I don't know the actual name for the calf muscles.
Oh, like the scientific name?
Sorry, am I quiet, loud?
Now you're better.
Test.
I turned you up.
Test.
Okay, you're good. You're good.
Don't forget to shout the N-word.
Don't forget to get me banned off Twitch.
Can you hear me now, you fucking...
Oh man.
Sorry.
It's
I'm
all
taking
good.
the piss.
We he's Dexter shirt's back. Yes, Sib, send me some questions. We'll do it.
I don't care what your skin color is, you're equally as worthless in my eyes.
No.
That's a bit of a that's kind of a thing from Full Metal Jacket, if you've ever seen it.
No, I haven't seen Full Metal Jacket. I thought that was from also like South Park, right? Remember in South Park, he says like, "I'm not racist. I hate everyone equally" or something. But is that from Full Metal Jacket?
Full Metal Jacket was in the 70s, I'm gonna say, maybe the early 80s. But yeah, there's a whole scene where the staff sergeant's walking through, just basically saying, "I do not look down on insert racial epithets here."
Yeah.
And another one, and another one, and another one. You are all equally worthless.
Yeah, that's the harsh thing. Okay, your thighs is apparently 21.5% of your mass distribution. Wow. Okay, look at this.
Is that for men or women, though?
Oh, this is for men. Yeah, I mean, I could do it for women. This was a 1955 study, though. This is quite old. Let's ask, like, okay, let's say, like, I'm working out different muscle groups. For instance, one day is chest. I don't think I do anything else on chest. I think I literally do. No, chest and back. That's right. The other day is shoulders and arms. The last day is legs. What percentage by mass of an average, I don't know, let's say 30-year-old male, am I working each muscle group day, whatever, like, just see what it says. I'm just curious. There you go. See? It says what it's doing. It's calculating some stuff. It's thinking. It's aware. Oh, it's also searching the web, dude. Dude, it showed me it was searching the web. It was going on like NIH stuff. What? Yeah, look at this. It's going to like some PubMed stuff, ResearchGate. This is actually pretty impressive.
It's interesting. You can train these AIs, LLMs,
yeah.
And I have specifically said, if you do not understand what I'm saying, look for the information on the internet.
And it will go find it, honestly. Okay, here we go.
It stops it from making shit up, basically.
So, it says here, chest and back is 14.8%. Shoulders and arms is only 5.8%. That's pretty low. And then legs is 19.4. So yeah. So chest and back is actually a pretty heavy day, I guess, too. Okay, cool. Oh, we learned something today. Yeah, leg day is the heaviest. But now we got the data. It's not 50%, though. I thought it was 50%. It's not. It's only 19.4%. But still a lot.
And of course, those ratios will be different between men and women.
Oh, yeah, interesting. Yeah, this was for men 18 to 35. Damn, I'm on the upper epoch of this. Fuck. I no longer belong to the 18 to 35 age group.
Oh, no.
I've become like one of the geriatric age groups of science. Oh, man.
People keep telling me I'm in my 20s, so that's kind of annoying me now at this point.
Oh, take it, dude. Yeah. I mean, you don't look, what are you, 40, 41? You celebrated your 40th birthday, I think, with us on a stream here once. Nice.
More than likely.
We got to get you over here for your 45th or something. The Sensation Tour of America.
I need to get back out of the country. It's been a long time.
There you go. Yes. I haven't actually been out of the country in a while, honestly. Will I be in Europe?
North.
Yeah, I think England is on my list. I think I do need to go to England at some point. Forget why. It's like a funeral or something. But when I do, I'll hit you up. Ooh, Sib, you got a good question. I like this one. Cool. Yeah, let's do it. And then Shantrix also. This is a good question. If you're hanging around Shantrix, we'll do yours. And then also equity. Let's do yours as well. Okay. Let's try this one. The equivalent capacitance between points A and B in the diagram is C1. What is C2 in terms of C1? Oh, okay. Well, I can't read any of this. Is this a C1? I assume it's a C1, is it? One sec, maybe I have like a... Let me find a better screenshot of it. I know what question you're talking about.
Why is it circular? That just hurts my eyes.
I know. Well, they're trying to mess with people. I know. Most circuits are never circular, right? Yeah, they're just trying to fuck with them.
I don't think you can have circular circuits.
I mean, you can have wires go in all directions if you really want, but it is weird to put them in a circle. Where is... This would be under capacitance, I think. I think this was a capacitance question. Yeah. Yeah, I drafted like half of their exam earlier this afternoon. I gotta do the other half tonight, and then get it off to my TA for corrections. He's always really good. My TA is awesome, honestly. Albert, if you're watching, I love you, dude. Yeah, Albert does a really good job at like figuring out what I did wrong. I love you some circular circuits. Yeah, dude. Look, dude, what is this? What is this, dude? And then sorry, what was the actual question? What is the equivalent capacitance between A and B is C1. Okay, so we say capacitance from AB is equal to C1. And they're asking, what is C2 in terms of C1? So, like, C2 equals, like, some constant. Let's just say, like, A. Or, let's not A. Let's just say X. C1. Cool. Okay. Well, maybe let's just try to figure out the equivalent capacitance for this whole thing first. So, here you have capacitors in parallel, and capacitors in parallel add up regularly, right? So let's call this like chunky block. Let's call this like, I don't know, like, yeah, fuck it. Let's call it like C1, C12. So C12 is equal to C1 plus C2. Okay. I don't actually know what law this is. Probably kind of like Ohm's law, I guess. Gauss's law is very useful, though. We do use that a lot, and that's gonna be a lot on the test. Okay, so now you have new resistor here, right? Or not resistor, sorry, these are capacitors. So now you now have this, and this is C12. Yes, I agree this is fucking goofy looking. And it would be nicer if we just drew it like this, right? This like pleases me, right? I'm happy with this. This is what it is in non-circular form. So this is C1, C12, C1, and then this is C2. And okay, so now you have 3 capacitors in series, but capacitors in series add up the weird way. So let's call this like chunky block. Let's call this like C. Oh, I'm running out of like letters. Here, C1121, because it's a 1, a 1, 2, and a 1. That's what I'm gonna say it is. So C1121 is equal to 1 over C1 plus 1 over C12 plus 1 over C1, and that's also the negative 1. I'm going to make my pen thicker too. Okay.
Why does that feel like resistance?
Because capacitors act like resistors, but in the opposite way when it comes to like adding them. So yeah, this form of adding things is usually for like resistors in parallel. But resistors in parallel act like capacitors in series. It's really goofy. Someone was asking me like why that is, and it kind of comes down to how they're related with voltage.
Hmm.
So
you'd think with me playing with electronic circuits for like the past 25 years, I'd know this
Sure.
stuff, but it's just me sitting there with a circuit probe going, does this component work? Does this component work?
Does this thing beep? Does it beep? Yeah, is there continuity?
If no, yeah. If no, pull component, replace component.
Right, exactly. Whereas, I mean, if you understand whether things are in series or parallel, you can start to maybe diagnose whether it's like one component's that's fucking it up or if it's like the whole thing is rotten. Yeah.
With things like NESs, they're just so old.
Sure.
And simple in relative terms, so it is just a case of there's not that many components. Does this one work or not? Right.
Like, it's nothing's like super complicated. Oh, Sib says, why is it CAB? Oh, sorry. So I'm saying the capacitance, this right here, this is the effective capacitance between A and B. And the reason I said that is because in the question, right? I mean, I think that's just like part of the question. Ooh, no, let's get rid of that. No. Yeah, because this was in the question, right? It said the equivalent capacitance between points A and B. And so that's what I'm calling CAB. So we're trying to find the capacitance between this and this. So I'm trying to turn this whole fucking mess here into like a single capacitor, and then just put it in between the two. And then we know that that's equal to C1. But then what is C2 in terms of all this other hot garbage? So first thing we did is I broke this down into a single capacitor. Then I broke these three down into a single capacitor. And now I'm going to break these two down into a single capacitor. So here we're going to get CAB, which is now all of this stuff, right? But this is two capacitors in parallel. And that's going to equal, because the capacitors in parallel just add up together, that's going to be C1121 plus C2. So that's equal to, what's up, Gmail user? 1 over C1 plus 1 over C12 plus 1 over C1, all to the negative 1, right? Because that's C112. And then we say plus C2. And then C12 is equal to C1 plus C2.
Imagine advertising that you use Google product.
Gmail user. That is pretty funny. Dude, Sergey needs to like chill out, dog. Have you seen him on the news recently, dude? Man,
Sergey?
Sergey Brin, the co-founder of Google.
Oh, yeah.
He's saying some wacky shit, dude. I'm like, yo, dog, chill. That's a redneck emoji. Is it? Looks like a dude with long hair and a beard, which when I had my mullet days was definitely me. Definitely was there, dude. Okay. This kind of sucks. So
I think redneck's the wrong word.
yeah, I think something that starts with
What's
a T.
what's the dickheads with the iMacs and the soy lattes and
hipsters.
hipsters? Yeah.
Yeah. Which I don't even know if that's a thing anymore. I don't even know if they call them hipsters. They probably just call them like e-boys or something. This adds up to 2 over C1. And then this is plus 1 over C1 plus C2. This is all to the negative 1 plus C2 is equal to CAB, but CAB is also equal to C1. Okay.
Good old hipsters. Oh, look
Good
at
old
me,
hippies.
I'm so special. Yes, but not in the way that you think.
Jesus was the first hipster. Ooh, that's kind of cool. Hot take, dude. Jesus was the first hipster. C1 plus C2. Plus C1, and then this is all going to be over C1 plus C2. This is just a messy question, dude. That's honestly pretty terrible. But okay, so what we did is I just combined the denominators here by multiplying this by C1 plus C2 over C1 plus C2. And then I just multiplied this one by C1 over like C1. And then I add them. And then it's to the minus 1. So that means you flip the fraction again. Butterfly method is the best thing ever. Yeah. Butterfly method only works when you're really doing this though, right? Yeah. But butterfly is when like you're trying to solve like one fraction equals one fraction and you just like top times bottom equals top times bottom. When you're doing I guess it's kind of the butterfly because like you're taking this and you're putting up this and then you're taking this and you're putting up this and then you're adding them together. Okay, maybe that's also kind of a butterfly. Very special. Okay, C1 squared plus C1 C2 because this is gonna flip. Okay, so maybe let's not skip too many steps. So C1 plus C2. Yes, Sib. Come on. What's that, Sib?
Hello there.
Hello there. Dang, this is looking like a real Texas mess.
Hello?
What's up, Sib? Yes. How's it going?
Hey, yeah, good. How are you?
What's
I
up?
was just trying to figure out like when you added the CAB, like where is that know that's part of the question, but this is the part I was like really confused about. Like, how do you know where to put it after you've like condensed the circuits? Like, how do you put that to? Where do you just like?
Sure.
You just add it to the whatever.
Like how did I do this?
Yeah. How you?
So this right here is combining this into a resistor. Not into a resistor. Sorry, into a capacitor that is literally right just in between A and B. Right. So this new capacitor represents the equivalent capacitance between A and B, because this is now just CAB. Or the other way you could write it is like, this is the same thing as C11212, right? Because this capacitor represents these two capacitors together. But that's the same thing as the equivalent capacitance between A and B, because it's the only capacitor in between A and B now. Does that make sense?
You just said it equal.
Yeah, you just said equal.
Yeah, you just said the equivalent capacitance gets set equal to whatever it was telling you before.
Yes. Yeah, just adding these things together. We're just condensing them down, right? I took this, I condensed it down to this, right? And then I took this, and I condensed it down to this. And then this and this condensed down to this, and then this is CAB.
Oh, okay. I see what you're saying. Thank you.
Okay, you're good. But I agree. This algebra is fucking messy. This is gross. I think this is gonna be a quadratic. What's up, Sensation? What would you read it as?
I would have read the question wrong entirely. From A to B, I would have assumed that it's an in and an out.
Oh, I see. Yeah, no. Yeah, it's in between the two. Yeah.
It's just a cross section of a circuit going in one direction.
Yeah. Y'all nerds? Yeah. Happy nerds. Capacitors in series add like resistors in parallel and vice versa. Correct, Fem. So correct, Femvox. Okay. I need to still solve. What am I solving for, dog? Oh, I need C2 in terms of C1. I'm a blue-collar worker, but seriously, this society is working because of y'all educators. Appreciate that, dog. I'm pretty blue-collar myself sometimes, dude. I know how to, like, weld and shit, but you're right. I don't actually do that for a living. I do that for fun. I go out to the desert and start welding things. Okay.
I move a lot of furniture. Does that count?
That's kind of blue collar, yeah. Being a mover, for sure, dude. Jesus Christ, dude. How are you supposed to rearrange this, dude? I gotta isolate. It's a fucking bitch. Okay. I think I have to multiply this on the top and bottom of everything, and then I'm just gonna cancel all the bottoms. I think that's what's gonna happen. That's really painful. I thought about putting this question on the exam, but now that I see actually how to do it, like, no. This is terrible. This is just painful.
Right, C2 times what?
Yeah. So we're taking this and I'm multiplying it by this, which is 1.
Right.
And then I'm also gonna multiply this one by the same thing. Woohoo, partial fractions. Yeah. We could maybe decompose in partial fractions. Yeah, it's a living. Yup. Okay, but here's the cool thing. Do you see how now everything has the same denominator? Now I can just wipe out those denominators. As long as that denominator is not 0, which we assume that capacitances aren't 0. What's up, Mohammed? My bro, dude. What's crack-a-lackin', dude? Okay, 3c1 squared plus 2c1c2 is equal to c1 squared plus c1 c2 plus 3c1 c2 plus 2c2 squared. Good? Nice, dude. I'm glad your day's going well. I'm in a land of pain right now. Because I'm trying to... What am I trying to solve for? C2. I'm trying to solve for C2. Okay. I think this is going to be a quadratic equation, is what it's going to be. So, we're gonna make this like... What I want is like something C2 squared plus something C2 plus something is equal to 0. And then this is going to be a quadratic. This is the thinking behind it. definitely quadratic, right? But I think students can get easily confused at like which thing is supposed to be like the variable that you're trying to identify the quadratic from. So you got to remember that we're looking for C2. So you want things to go in the order of C2 squared, something C2, and then something not in front of C2. So let's identify what C2 squared is. C2 squared only shows up here. Okay. So I'm going to assume the right side is what we got. Okay, so we got 2 C2 squared. Awesome. Cool. That's the C2 squared. Let's go find the other one. A nice way to proceed is to divide both sides by C2. No, don't do that to me, Fembox. What? Why would I do that? Divide by C2 squared? Why?
How rude.
How rude. Maybe Fembox might have a good idea. Well, Fembox is pretty smart, so I trust Fembox sometimes, or a lot of times. Then you get a quadratic expression in the ratio. Oh. Yes, I understand. I understand what you're saying, Fembox. That is true. Okay, but for this one, okay, now I need things with C1, C2, or like just a single C2. Like no C2 squared, just C2 to the 1. And that's 3C1 plus another C1, so that's 4C1. And then we're going to be minusing 2C1. So that's 2C1. So we're going to say plus 2C1 C2. And then finally, we look for something that doesn't have any sort of C2 or anything in front of it. And that would be this one and this one. And so when I move that over, that's going to be minus 2C1 squared. And this is equal to 0. Holy shit. Okay. So then, you sense a golden ratio? Oh, if I divide by 2, yeah, look at that. Okay, so let's just divide the whole thing by 2, right? So now I get C2 squared plus 2C1. Sorry, plus C1, C2, minus C1 squared, minus C1 squared equals to 0. It's almost a perfect square trinomial. Right? Wouldn't that be so nice? Only physicists can divide an equal sign by 2. We're ungovernable, dude.
Oh, no.
Okay. All right. X equals negative b. Okay, so we say like C2 equals negative b. So that's negative C1 plus or minus the square root of b squared. So that's C1 squared minus 4 times 1 times negative C1. C1 squared. Wait. Minus 4ac. All over 2a. Okay. So now that's equal to negative C1 plus or minus the square root. This is C1 squared plus 4C1 squared. So that's going to be 5C1 squared. All over 2. Oh, look at that. I can pull out a C1. That's pretty fucking cool. So C2 is equal to negative C1 plus or minus C1 square root of 5 all over 2. If I pull the C1 out, I get that C2 is equal to C1, and then this is going to be, let's put it on negative C1. Negative C1, and then this is going to be 1 minus plus the square root of 5 over 2. Or actually, no, fuck it. Actually, sorry, I want to leave the C1 in. So it's negative 1 plus minus. Okay. So that's equal to C1 plus or minus the square root of 5 minus 1 over 2. But minus doesn't make any sense. Right? You can't have negative capacitance. So it must be the positive solution. So you get that C1 is equal to square root of 5 minus 1 over 2. Almost a golden ratio. Almost. Okay, and I think that was the correct answer. Yeah, if we go here. Yeah, look at this. Damn. That's pretty hot. Look at that shit. There we go. We did it. Oh, yeah, I fucked up. Sorry,
Right,
C2. Yeah, does that make sense, Sib? Sorry, I
Yeah,
screwed
it
this
does.
up.
Thank you. I just had, and you know, the last question I have, I guess, is you were the other day you were like doing different problems with finding the capacitance per unit length over like a variety of different geometries. I was just, I think you said x is equal to 0 at some midpoint between wherever the radius was starting between like, for example, two cylinders, and then. So do you always just pick like the midpoint between the edge of both, like for example, cylinders, to be like X for one of the electric field components, and then the other one is just like the distance between both radius minus that X from the left-hand side? Like it's always that sort of arithmetic for the electric field, like the denominator.
So usually you want to define x equals 0 as the center of one of your devices. So I know what question you're talking about. You're talking about this one, where we have like the two cylinders, like this. Yeah, and we're finding the capacitance in between.
Yeah, that's the one.
Okay. In that case, I set the center of one of these things as x equals 0. So then I think this is like x equals a, and then the distance, right, from center to center is equal to b. So going to here is then like oh, I get it. So that's going from x to b minus a, right? See how like if you're going here, because this is also a. So this is going out to x equals a. This is going out to x equals b minus a. And that's for calculating the electric field due to this one, right? But then we're looking at the electric field from this one, right? That ends up going from I gotta remember how the distance here works. Oh, whatever distance this is this way, this ends up the distance from this center to here, because that's how you measure electric field, is from the center of whatever the charge distribution. This is like here. This is R1. Let me just write this out. This is R1. This is R1. Okay, so that's referring to the radius of this. But as we go further out, the radius in reference to the second thing here, which this is like R2, this is equal to fuck, how's that gonna work? This is equal to b minus x. Because whatever distance this is out in x, b minus that distance will tell you what this distance is, which is the radial distance of the center of the second object to where you're measuring the electric field or the current or the potential.
Okay, so it's basically if it's the same thing as measuring like from the middle of the cylinder to the midpoint in between them. Like if that's x, then the other one would be b minus x.
Correct. Yeah.
Okay.
And it doesn't have to be the midpoint; it just has to be somewhere there. When you're calculating capacitance, you need to integrate the potential from this side to this side. So on this one, you end up doing like whatever the kq, whatever. I think it's like 2 lambda, and then this ends up being just over x. But then this integral, right, is from a to b minus a, because you're going from x equals a to b minus a. But then the other one is minus, because it's an opposite charge distribution, right? And then that goes, I think, the same a to b minus a, but instead of x here, this is now b minus x. Because this is R1, and this is R2. So, like, this is the electric field due to the first one, and then this is the electric field due to the second one. And X always refers to something measured away from the center of the first one.
Okay, but weren't you saying yesterday?
I think this is a plus, though. I think this is a plus. Sorry, my bad. This is a plus.
Yeah, the plus, because then they would subtract,
yes.
right? It would be 0. Okay.
No. The reason why there's a plus here is because when you're doing this integral dx, or in this, or X is technically pointing in this way, but for the equation of electric field, R points in this way. So you end up getting like, another minus here, but you also had a minus on the charge distribution because this charge distribution is opposite to this one, and the minus makes it a plus. Also, you can think about it if this is positive SIB and this is negative, right? Electric field will point in this direction for the first one, so it'll point towards the right.
Yeah.
But then electric field must also point towards the right for the second one, right? The second one is going to do this, right? The arrow moves towards the charge distribution. So these two, the electric fields have to add. And that's like an intuitive way to know it.
Oh, okay. That was my next question, is because you canceled out the negative yesterday or whatever day it was. I was wondering why, but now I understand. Thank you.
You're welcome. Nice.
All right, have a good one.
You good? Yeah, you're good. Feel free to ask more questions throughout. Let me see. Gmail user says, man, after watching your live class, I remember my school days. Feel so nostalgic. I dropped during junior year. Wish my mama had told me to study hard. Aw. Well, you know, you're doing a good job right now, dude, because you're still learning right now. That's pretty sick.
That's dope.
We all didn't have, you know, the same parents to tell us ahead of time, like, what's valuable and what to do and what not to do. Some people don't even have parents, you know. They just, like, they're wards of the state. They just got to figure it out, or whatever, like, TikTok tells them to do. But Gmail says he's been doing the truck driving and small transport since then. I'm 52 now. Time flies so fast. Nice. I like trucks. I'm a big fan of trucks. I think, you know, honestly, like, also truck drivers get paid fucking bank these days in the US. It's like one of the few jobs I think that is kind of impervious to AI. Even though they thought it was going to go away, right? We thought that AI truck drivers would replace truck drivers, but I don't think anyone trusts AI to move like a 30,000 pound vehicle. It would just like end up wiping some people out. Maybe it doesn't pay a lot. I thought it did. Go on, Sensation.
The question is, whilst he's trucking, does he listen to Convoy?
Convoy. Do you listen to Convoy, Gmail user? You listen to Convoy? I don't know what the reference is. What's the trucking reference to Convoy?
There was a song in the 70s called Convoy. I'll look it up.
Oh, go look it up for me.
It's about trucking.
I think honestly, I love driving. If I had the choice between, do you want to get on a plane and fly somewhere, or do you want to drive there? I'm like, yeah, let's drive, because I don't know, there's just something cool about being in control, and just I can drive for days. I love when my job is just like, get this vehicle from here to here. I can just do it. It's like autopilot. It's so much fun.
Let it fly.
Yeah, flying feels like cheating, dude. Feels like, I don't know, dating a stripper or something, right? It's not real, you know? You didn't actually, like, do much to get there, right? Whereas, like, actually driving a car is like taking a girl out on a date. Like, you have to put some work in. Plus, you get to see things. It's really cool to see America if you drive through it versus if you fly over it. There's a lot of really cool stops, a lot of different people, for sure. Dude, I noticed that this weekend when I was in Michigan. I was like, oh, wow, I'm not in Los Angeles anymore. Michigan is a very different place than LA. Josh says that's a crazy comparison, but I get it. Yeah. What I mean, Sensation, like in the UK, if you drove a lorry right across the UK, would you notice like a big difference between like the areas of England?
Not really.
Not really.
If you go outside of England, the geography changes,
but like within it's like it's pretty see, the US is crazy because you have like the mountains and the forests and stuff in one area, and then you got like deserts. Yeah, right. Wyoming to Kansas, and it's just gonna be plain field. Exactly. Some of it is like stupid boring. Like going through Kentucky, very boring. Going through where else did I drive through? Like Arizona, depending which route you take, can be pretty boring. You go up through Flagstaff, it's beautiful. What's up, Amelia?
The only difference is sort of population density, but then from an American perspective, it doesn't really change.
Yeah, I mean,
the further north you get, the more sparsely populated it becomes. until you reach the borders of either Scotland or Wales, and then it becomes kind of hilly.
Speyside. I want some scotch. Where's my drink?
But that's whiskey without any.
Yeah, I do like Irish whiskey. What's up, Amelia? If you got a question, Amelia, let me know. I'll do it. Here, I'm gonna try to do Shantrix's stuff. It's just all isolated once we exit the suburbs. Yeah. Yup. Yeah, math. Jeff loves math. Jeff, what, are you tired of the physics we've been doing all summer, dude? I agree, Shantrix. Yes. If you like the landscape. Dude, driving through, I don't know, like Northern California, Colorado, it's gorgeous, dude, to drive around there. It's so nice. Millie says, I'm wondering if we can solve more equivalent capacitance problems. The circular config. Yes, I just did it, Amelia. Yeah, I literally just did that one. This was here, let me actually get rid of all this. This is something else. But if you want, yeah, there is a DVR feature. If you want to see, this is all the math that was required to do this one. Yeah. So maybe like rewind like 10 minutes or something. You can watch the recording too. Yeah, cool. Yeah. This was kind of a pain in the ass. I don't think I would ask one of these on the exam. I mean, certainly not requiring you to do quadratic equation and stuff. This sucks. I would definitely ask you to like simplify a series of capacitors, which honestly we got it simplified when we got to here. Like, this was fine. The issue was that we then had to set this equal to C1, and then that became like a huge mess of math to go do that. But the concepts was there. Yeah, it kind of sucked, honestly.
Oh no.
But if you find another one, let me know. I'll do it. Let me try to do a little bit of Shantrix's because you've been waiting. Okay, ADB has side C on BD. Also, BC is equal to 2. Cool. CD is equal to 1. AC over AD is 3 to 4. Oh, that's a ratio. Oh, so that's not actually that. Can I ask a question? I've been asking for 3 hours. We've been streaming for 43 minutes. How have you been trying for 3 hours? It's false, Caleb. What? No. We've been streaming for 43 minutes. How have you been trying for 3 hours? Also, yeah, if you have a question, throw it in the help screenshots. That's where it is. Oh, you've been trying for 3 hours to solve it. Oh. I mean, you can ask it, but I might punt it, because if you've been taking 3 hours, it would probably take me like 5. Okay. AC, AD is 3 to 4. What's our frozen fusion? And then cosine of ACD is equal to negative 3/5. Negative 3/5. Oh, because it's negative. Duh. Determine the length of AB. And they give me this side. That's tricky. Law of cosines? Yeah, I was thinking law of cosines as well. You're right. On this angle. I agree with that. Let's do that. So law of cosines says c squared is equal to a squared plus b squared minus 2ab cosine c. In that case, that would be AD squared, which I don't know. So AD squared is equal to A squared, so AC squared, which I still don't know, plus B squared, well, that's 1, because that's this one, minus 2, and we're going to say AC times 1 times the cosine of ACD. Very cool. But the cosine of this angle ACD is equal to negative 3/5. Nice. Dude, I do not want to draw no auxiliary lines, dude. I'm not drawing auxiliary lines. I refuse.
Oh no.
Okay. Great. What did that tell me, guys? It told me what AB was, I guess. Substitute AC equals 3/4 AD. Ooh, I do like what you're cooking there, Jeff. So he says, what about this? We could take that and substitute that in for AC. Do I want to get AD, though? I guess I can, because then I just get it. Yeah, alright, let's do it. Fuck it. So, AC is equal to 3/4 AD. So then that's AD squared is equal to 3/4 AD squared plus 1 minus, so plus 6/5 3/4 AD. Is this another quadratic, dude? Oh, law of cosines again. Okay. So we got a quarter. Oh, wait. Actually, sorry. No. So this is AD squared is equal to 9/16 AD squared. And then this is plus 18 over 20. 9/10. Plus 1. Okay. I see some quadratic stuff going on. So this is 0 is equal to -7 over 16 AD squared plus 9 over 10 AD plus 1. Allegedly frozen. Do I have to quadratic formula this, Fembox? Do I really have to do that? I don't really want to. What's up, Zach? It factors. It does? Okay, well, fuck this. I'm not doing the quadratic equation. This is the question we're doing, Zach. Triangles are beloved, dude. It factors. How does it factor? What common factor are you multiplying by? I have like tenths and sixteenths. I don't like these things. I guess common factor is 80, right? Is that the first one? 80, right? So this is the same thing as -35 AD squared. Yeah. We'll multiply by 5 on one and multiply by 8 on the other. Plus 72 AD plus 1. I'm not seeing the factoring. I don't see how you have factoring here. What multiplies to -35 but adds up to 72? That doesn't really factor, does it? No, none of that factors. Okay, I did something wrong then. Yuck. AD squared equals AC squared plus 1 squared minus 2 AC1 cosine of ACD -3/5. So that's -6/5, +6/5. And then we have AC is a 3/4. So yeah. 18 over 20, 9 over 10, plus 1, squared, 9/16, subtract. Yeah, I'm okay. Yeah. Okay. I'm gonna throw this into Wolfram or something. So I'm gonna say -35 x squared plus 72x plus 1 is equal to 0. Solve this. Wait, what? Where is it? There we go. Okay. Solve for x. Give me something.
72.
I just don't want to do it. Oh my god, you can't fix the latex. That's not really nice. Dude, that sucks. What did I screw up, boys and girls? Yeah, no, this doesn't factor really nicely. What the fuck? What the fuck did I do? Excuse me. AD squared. A squared plus B squared, right? We said CD is 1 minus 2AB AC cosine of ACD. -3/5. Yeah, chat doesn't. Yeah, ChatGPT doesn't want to do it either. Do you have to use the positive cosine? That's a good question. Do you? Okay, let's see where I fucked up. Oh, wait. I did solve for AD at first. It should still factor nicely, right? Yeah, this doesn't factor though. Oh, I see. Yeah. This should be plus 80. There we go. Let's try that. Yep. Thank you. Okay. Yeah, I forgot to multiply that also by 80. Bum bum. Say like, I mistyped. Instead of +1, it should be plus 80. Forgive me, ChatGPT. There we go. 20/7.
That's dope.
Okay. AD equals 20/7. Okay. Now, if you know this is 20/7, then that means AC is equal to 60/28, right? So that's 30/14, 15/7. Okay. Cool. And then what? One last law of cosines? One last law of cosines for this one? So then this is AB squared is equal to, what's that 1K? 15 over 7 squared plus 2 squared minus 2 times 2 times 15 over 7. But then it's cosine of pi minus ACD, right? Which is that the sine of angle ACD? Or you can actually just build a triangle, right? Can we just build a triangle here? Because -3. This is 5. That means this is 4, right? And this is angle ACD. And we're doing the cosine of pi minus x, which I think is equal to sine of x. Is that right? And so the sine would be equal to 4/3. Or 4/5. Oh, cosine of pi minus alpha is negative cosine of alpha. Oh, okay. So I remember your trick, boys. Fuck that up again. Thank you. So this is going to be equal to positive 3/5. Nice. Okay, and then we just solve this. So what's that? 225 over 49 plus 4 minus 60 minus 180 over 35. 4, yeah, 60, 180 over 35. 4, cool. And that's all equal to AB squared. This doesn't really have any nice factors, does it? I mean, maybe. 7 going to 225? I don't think so. Doesn't. Oh, they both do go into 7. Both have a 7 in there somewhere. Sorry. I am harmonizing with the... I'm sorry, I am. I'm having too much fun with this. Sorry. This was plus 4. 140 over 35. So that's 225 over 49 minus 40 over 35. Bro, what is the common factor of 49 and 35? I don't want to do that. Okay. More ChatGPT. Just because mentally I can do this, I just don't want to. Solve. I don't want to multiply them both out. No, it's 49. Should be... Jeff says the answer is just 7. Let me see how they do it. So they find the common denominator of 245. Oh, so I don't get something nice. So I must have screwed up, right? Okay. Oh, it's not 46 over 35. Oh, it's 40. No, sorry. ChatGPT can't get my OCR right. Okay, there we go. Wow. Okay, 13 over 7. That's cool. Fine. It was going to happen eventually. Cool. We did it. Nice.
Good job. Well done. Well done.
Man. That had some cool concepts, but was just fucking ugly with algebra. Just so ugly. I mean, it came out nice at the end, but I don't know. It's just so many fractions and dealing with things. I get why it's a competition problem. It's meant to just like slow you down.
Flu.
Amelia, did you have any physics questions before I start diving into other things? Let me know. Halef is giving me... Yeah, what do you got for me?
I got that, that link there proves that COD is just an inferior copy.
I see. I gotta continue as my Facebook account. Oh, here we go. Is this COD? No, this is GoldenEye.
It is.
Oh, dude, this game is the tits, dude. I love this game.
COD is just an inferior copy.
Ooh, ooh. Pew! Is this like a walkthrough?
It just came up on my feed, and I was just like, now I remember what shooters should look like.
Yeah. Amelia says, it's really just the equivalent capacitance problems. You did one in the Office Hours 2 hours ago, another config. Yeah, how to explain to rewrite the configurations? Yeah, for sure. Let's just go through some of them. I'll show you how to like rewrite them. Well, this one I already did, but let me like just like not solve them. So here, let's do that one. It's still uploading Alef's. Yeah, you're good, Amelia. I got you. Well, this like broke my upload now. God damn it.
Please stop uploading 40 megapixel images.
Yeah, Jesus. Okay, there we go. Okay, we got this one.
If you can't use a computer properly, just don't.
Just don't. Just stop. Just stop.
If you're taking a picture with your phone and uploading it, don't. Just
Stop. Just go get some help, dude. Okay, let's look at these two examples. So I always like to define that one of my points is going to be positive. Okay. And then one of my other points is going to be negative. And then what I'm going to do is like anywhere the wire directly connects to a component and doesn't like cross any other components, I'm going to write the same charge. So for instance, on this one, right? This one comes here, makes this positive, and then it spreads out here, and it makes this positive. Okay. Then if we look at here, right? This is going to come down this way. Make this one negative. It's going to come this way. Make this one negative. Okay, cool. Now, capacitor maze. It really is. It's kind of fun. Oh yeah, this is the weird one where like the middle one doesn't do anything. I remember this. Okay. So let me like try to redraw what we got so far. So I know I have something up here, right? And it's going so far to here. Let me label all these first. Let's do 1, 2, 3, 4, 5. Okay. So now I know I have C1 here. Then we have also going to C2 here. And then coming up from the crypt. I have C2, which I'm going to put here. And then I have like C4. Okay. Now, on the end of C1, which I don't know what the charge on that is yet, so I'm just going to put it here, right? That's going to be like C1. I have that connecting eventually to the end of C4, okay? So these two do connect to each other, like this. Right here, let me make like a little thing like this. So again, as long as you're not crossing any components, as long as you're not going over anything, you're fine. So I know that happens. So that tells me this is true. Okay. And then this one, for instance, right, connects to the end of C5. Oh, sorry, this was C5, not C2 on the bottom here. What's with these problems? So, yeah, I'm teaching a E&M class at UCLA, and this is kind of some hard homework questions that are on their exam that's going to come up tomorrow. Or, sorry, Friday. So they're asking about it. Lurk. Yeah, Jeff is like, we're doing physics. Come on, Jeff. Come to the dark side. Okay, now here's the cool thing. Right? So that connects C1, C4, C2, C5. Oh, yeah, I've definitely already done this one, yeah. Oh, but this is a common thing that happens with, like, office hours, right? Is a lot of times you'll get students that are just coming back to try to figure out what I've already done. But it's okay. I can't tell you how many times... so the nice thing about this being online is if I have, like, literally just done a problem, I can tell a student, hey, go look at the recording. Because I literally just did it. When I would do office hours in person, so at the beginning of my office hours, right, people would be in my office, they'd ask a question, be like, cool. And then towards the end, like, someone would walk in and be like, hey, can you do that one question? I'm like, oh, fuck. Like, I already did it. But I don't have a recording to show them. So that I'd literally have to do it again. But I don't think I've done it with, like, the colors here like this before. So anyways, this just shows that, like, this one connects right to the green line of this. And then this connects to the pink line of this. And then this is C3. And this is kind of like a wheat stone, actually. Yeah, wait, yes, these colors are really helpful. Yeah, I know. Yeah, which this I can't really do on a whiteboard. So, equivalently, this just becomes like this. All right, here. Eek. Let me do this the right way. And then this is like, yeah, C1, C2, C4, C5, this is C3, and then this is A, and then this is B. Now, the argument, so C3 can be removed if all the other capacitances are the same, I think. Well, actually, no, C3 can always be removed. You're right, Fembox. Because this is a parallel leg with this, right? And then parallel lines should have the same voltage. C3 is always removed. Correct, Josh, right? Yeah. This is parallel to this. Parallel things have the same voltage. If you have the same voltage on both sides of a capacitor, you don't have a capacitor anymore. You have to have different voltages. Yeah. So that's the argument. You can kind of remove C3. And I think, let me see if they had that in like the explanation for this one. Did they have a detailed solution? Yeah, here, let's see what they said. Yeah, cool. So look, they get the same like kind of analysis of what it looks like, right? From symmetry, it is clear there can't be a potential difference between points D and E. And therefore, the capacitor between these points does not participate. That's dope, right?
That's dope.
Yeah, that's pretty cool. Thanks for the follow. Sorry, let me go through chat real quick. I saw in the other problem, one of the capacitors was positive, the other end was negative, so we're not assuming the charge on each other end is V minus. Yeah, so if you're looking at the charge on everything, how it works, right? This is plus, this is plus, this is minus, this is minus, this is plus, this is plus, this is minus, this is minus. And that makes sense because this is probably minus and this is probably plus. And then, yeah, there's no difference in charge here. So our C1, C4, C1 and C4, C2 and C5 in series, and then that collapses. So no. So here's what happens. If you wanted to collapse this circuit, this ends up being, yeah, there is no charge on C3. This ends up becoming, so here, let me copy this. A and B are the same polarity? I don't think so. You think they're the same polarity? How can they be the same polarity? In a capacitor, you need a positive and a minus sign. Okay. So once we've removed C3 here, Amelia. Yeah, not quite. Yeah, you're saying that these, they're not. Yeah, they're not. It's the same thing if you have like two capacitors. Here, let me show you. Oh, I fucked up. What's up, Nick? So here, this is what capacitors look like. So even though this is Femvox, right, the same wire, it doesn't mean charge is distributed equally on the wire. So in this case, this is positive, this is negative. The negative plate here will pull positive charge to this end of the wire, and the positive plate will pull negative charge to this end of the wire. Yeah. Yeah, all good. No, not your bad. That's good. That's actually a commonly misunderstood thing. I'm glad you asked it.
Hello.
What's up, Ethan? C1 and C4 are in series, and C2 and C5, and those become parallel. Correct, Amelia. So, this right here is series, and then this is also in series. And so what you end up getting, and then those are in parallel with each other, right? So then what you have is, you have A, and then you have this, which is like C14, and you have this, which is C25, and then this comes down to B. Yeah. And then these are in parallel. So you end up getting just a solid, just one capacitor, which is like this. So this is A, and this is B. And then if you wanted to figure that out, right? So this would have been, so C14 is equal to 1 over C1 plus 1 over C4, all the negative 1. C25 is equal to 1 over C2 plus 1 over C5 to the negative 1. So then C1425, which is what this one is, that's going to be equal to, now if they're in parallel, you add them up. So that's just going to be 1 over C1 plus 1 over C4 to the minus 1 plus 1 over C2 plus 1 over C5 to the minus 1. Yeah. That's pretty cool. Nice. What's this coin system?
RTFM.
Yeah. There you go. There's a channel for it. People don't. Yeah, it's all good. Okay, cool. See, let's see if that same thing applies to this one real quick. Oh, circuit diagrams. Hey. What's up, Zebediah? Yeah, we're doing capacitors here. Capacitor diagrams. You did this. Weren't you like a bioengineer or something, dog? You were a bioengineer, yeah, weren't you? My Prime sub didn't pop up. I want clout. Why did it not? Wait, it'll pop up. Give it a second. Give it a second. Give it a second. It'll do it. It'll do it, dude. It just takes time. Yes, BS in biomedical engineering, right? So you probably had to do something with circuits, no? Dog? What?
You know, I wanted to say something.
What do you want to say, Ethan? What's up?
So you know how you have GSCE over at where you are?
I don't.
Me.
Yeah.
Oh, right. I thought you had the same thing. Well, I remember
I don't live in the
these,
UK.
like, okay then. But they have these physics questions. Like it's kind of we have a GSCE, but it's something different.
Okay.
But, I took the physics one, of course, since I love it, and they actually asked some circuit ones. But it's like I just memorized answers because I did not know how.
No, you don't need to memorize, dude. You should figure out how things actually work.
Yeah, I know, but I just did that quick time because I was never taught circuits in high school.
Yeah.
I hate when I have to memorize stuff, and I hate when I have to cheat sometimes as well. Like I hate those two things.
Well, that's good. I'm glad you have an aversion for being a weak student. That's great.
Wait.
You should want to understand stuff, but I get it. Like sometimes you just have to memorize shit because like you have a test and you're like, fuck it, like I need to pass.
Literally, like the company is literally lazy with like the first paper. They literally just reuse questions and I just memorize them and they just pop right back into the same thing. So
I get it. Yeah, no, they totally do. Yeah.
But also I wanted to talk about something that happened yesterday.
What happened yesterday, dude?
Remember how I said I was watching a baseball game?
Yes. What baseball game were you watching?
It was in Denver. They have their team called the Rockies versus.
Wait, you're watching the Rockies, dude? The Rockies are one of the worst teams in baseball right now. Were you at the game?
Yes.
Oh my God! Wait. What's sorry? I gotta pull up the Rockies winning record, dude. What?
Wait. Well, yeah, I heard that they lost a lot of games, but they actually won that game yesterday.
Oh, they did. Wow. Yes, Heber. I am the best. I heard physics 5A with Professor Rossi is the best. There you go. Apparently their winning percentage is now 0.24, which is better. It used to be 0.162, which they were on pace to finish the season with the worst record ever.
Oh gosh.
Yeah. They were gonna be the worst one ever.
I mean, hey, I watched the game. At first, I was.
That's cool, man, dude. I mean, like, sports games are dope. I'm glad you got to experience that. That's pretty cool.
I mean, at first I was just bored, but then as the game kept going on, I was just more excited and excited and excited.
Nice. And they won? Who were they playing against?
Cardinals.
Cardinals. Okay, cool.
But yeah, I'm sorry I had to answer only in the chat, but
No, you're fine.
I mean,
I can still understand you. You're okay.
but yeah, this time I can speak in voice now and I can answer in voice. I already have my question posted up.
Good. Okay, I'm gonna do it in a second. I need to figure out how this one works.
This
This one's a little trickier, Amelia. How does this work? So this tees off and hits. Oh, dude, watch this, Amelia. This is super cool, actually. Watch this. Yeah, dude, look at this. The geometry's throwing me off, right? Yeah. Okay, but watch. This is actually really cool. I'm gonna use a different color here. Do you see how like this leg, right, then tees off and connects with C2? So here, let's mark these. All right, this is C2. Hebrew, when are we gonna play the finals again, dog? Like, no one wants to play the finals anymore. I'm so sad. It's such a fun game. You want to play tonight? Let's play tonight. I gotta write an exam, but then, cause then like I don't have class on Monday or Friday, sorry, because they're just taking the exam. Yeah, do you see what's happening here, Amelia? It's really cool, actually, right? Because look, now this part tees off to the other end of C3. Look at that. Oh, that's super dope. So now it's just 3 capacitors in parallel. So then C123 just equals C1 plus C2 plus C3. That's low-key beautiful. I think it is, dude. It's really cool.
Damn, man, look at that, look!
That's pretty cool.
That's messed up. Okay, Heisenberg. Next week.
Next week. What's that character's name, dude, from Breaking Bad? What's his name? Paco or something? Poncho? He's the crazy guy. Tuco! That's it, Tuco. Yeah, Tuco's nuts. Fenvox says, I think this is how some variable capacitors work. A lot of interleave plates that are all connected to the same 2 nodes. Yeah. You just started that series? Nice. Okay, thank you, Zev. Yes. I was exhausted and or taking a break from the PC after a crazy long session. Yeah, I've lost you to Marvel Rivals. It's okay. Nice. Yeah, Breaking Bad, I think, is one of the best series, I think, ever in any like TV show. It literally doesn't have like a dull moment. It's really, really good. Which I should watch Better Call Saul. That's like the next one. The finals lost me. Yeah. You want to ask if I do these during the school year? I do. Yeah. We've been doing this. This is a nonprofit. We've been doing this for how long? 4 years? 4.5? Yeah, a lot. So, yeah, I always tell students in my classes afterwards, I say, hey, if like you have a physics professor next quarter and they like suck and like they don't have good office hours, like you can come to the stream and I'll help you during whatever these office hours are. Yeah, you're good. I'm taking 1C with Corbin and I'm actually terrified. Yeah. It's okay. I heard his tests are just kind of meh. I heard he's a good lecturer, but his tests are terrible. Which I'm like, bro, don't ruin your legacy on like just trying to beat kids with an exam. Life is short, dude. As long as you keep. What's the idea? What's the idea?
Beating kids with an exam. You will fucking learn.
You will learn, dog. Yeah, I've heard he's a great lecturer, but his tests are like below 50 averages. Yeah. I don't know. My philosophy on that is that if you're giving out a test and the class is getting a 50 on it, that's not on them. That's on you, dog. Like, you screwed up. Like, there is like some minimum standard we should have for like you need to know this, but if the class is getting a 50, then you either didn't teach it or you severely miscalibrated or whatever, like the amount of time it takes to take that test and the aptitude of your class. Nah, kids are dumb. They need Eastern European parenting. It sounds like give them the beatings, dude. Like my papa used to beat me. I had one student ask me if they could take the exam at a different time because Friday is their birthday. Like, what? I was like, I had to tell him. I was like, yo, straight up, dude. Like, you could have come up with anything else. You could have said that, like, I had a family emergency or blah, blah, blah. But if you ask a professor to move an exam because it's your birthday, you're going to get fucking laughed at. I don't know. Bless these kids. Yeah, Zach. Look at Zach. Zach's just like, Zach, yeah. I want to make a book of all the emails I've gotten teaching so far. I'll strip them of all like the personal information, but I just want like people to understand like what I deal with as a professor, like listening to some of these emails.
So they really made an excuse just because it's their birthday.
I don't know if they made like an excuse, but they made a request, and I think this comes down to I have a lot of philosophy ideas on this. Like, also once you're behind a keyboard, like a keyboard warrior, you feel like safe to like say whatever the fuck you want. That's why you have people just yelling the N-word on the internet, because they're just like, oh, but I'm behind a keyboard. No one can I don't have to deal with actual consequences. So if you're emailing your professor like what I think is a ludicrous request, there's no consequences, because you're just like, oh, well, I'm safe behind a keyboard. So I can just ask, hey, it's my birthday. Can I take the exam at a different time? That is far from the funniest email I've gotten. It's a good one. One second, let me catch up on chat. Sorry. It's hard to lead by the carrot when they really need the stick. At least bro is honest. Yeah, I did give him credit for him at least being honest. I said thank you for at least, not coming up with a bullshit excuse. I wanted to tell him like, hey, but next time if you're gonna pull this with a professor, try to come up with something a little bit more creative than it's my birthday. I need to change my username? No, dude, no. I can separate the Jews from the state of Israel. It's sad that some people can't. Like, yeah. I don't think you need to change it. I think it's fine.
Was?
People
Juden?
You did?
I'm joking.
You did?
And also, Dr. Go, like, I want to say something.
What's up, dude?
I've been recently getting back into Fortnite with like, since the house I'm staying in, they literally have a PS5 here.
Wow, that's super nice.
I've been playing Fortnite. I've been getting a couple of wins recently.
Oh, that's
Not
good,
that
dude.
good at the game anymore. Not that good at the game anymore, but I'm still getting my skills back. And also,
we're gonna do games on Sunday. We're gonna do them on Sunday, by the way. Saturday I gotta do a cookie run. So my friend's sponsoring some like thing where we go run 5 miles and we eat a cookie like every mile. So I have to do a cookie run. There's just a lot going on Saturday. So we're gonna play video games on Sunday, and we're gonna do Roblox.
Like for the rest of the time, will it be on Sundays? Because that's when I can play. Like on
Maybe.
Saturdays I can't play because
We'll see. Well, I'll see what's like convenient and like what works. Sorry, let me get Aleph Null's question. He has been like waiting a little bit. Aleph, I apologize.
Anyway, the thing about coming out with bullshit excuses for like
yes,
it's my birthday, can I put off exam? See, I think that's more down to the fact that in the US you treat people like children until their 18th birthday.
yeah, but this is a college class. This kid is probably like 19 or 20 at least.
Yeah. In this country, it's like, no, you've left primary school. Fucking sort your head out.
Yeah. I think it comes down to the fact that they know there's kind of like no harm in asking, although there is a harm because I get frustrated. But and it's also this theory of like the squeaky wheel gets the grease. So like if you make the most noise and like blah blah blah, you tend to get like preferential treatment. And I think this is okay if you're making the most noise, for instance, coming to office hours and asking physics questions. That is like good squeaky wheel. Like, because yes, and I do this. If I have students that show up to office hours all the time and ask questions all the time, and I see like whatever, they're on like the cusp of some like grade thing, I'll just bump them. Like, because I'm like, you actually put in effort, and it does like make a difference. I can't quantify it. I can't like legally put it in on a syllabus because then I'd get like absolutely like sued. But to people that are watching, and if you're, yeah, it is always a great idea to go to office hours, because I guarantee you the professor notices, and if there's any like question about leeway or slack, they're more likely to give it to you if you show that you've been putting in effort. They don't penalize if you don't, but you don't get a bonus if you don't do it. So be a squeaky wheel in that way. You can totally be a squeaky wheel asking for like help in physics. Don't be a squeaky wheel asking for, hey, can I get this extension? Hey, can I get this? Hey, can I get this? And then there's like no justification really for it. Yeah.
See, I much prefer the Japanese methodology.
What's the Japanese methodology? Just harikari, seppuku?
The nail that sticks out gets hammered down.
The nail that sticks out gets hammered down. Ooh. That's an
their
interesting
like
one.
national ethos.
That's nuts. Wait, so they're really homogenous, the Japanese? I thought it was like the Chinese. The Japanese are really homogenous too?
The Japanese are genetically homogenous, but they're fundamentally different. I was talking about this the other day. So we in the West, or rather you, and then it kind of migrated to us, is where the individual is the center of the universe.
Yeah.
So it's kind of gone from, it's kind of reached a point now where it's like an individual gets all their rights given to them without question, even if it's destructive to the country itself. The Japanese, on the other hand, they're a collectivist society.
Sure.
And so the individual's rights do not exist. You exist for the sole purpose of the country.
Ooh. For like the good of the people. That's cool. It's kind of communist, no?
In a way.
Yeah.
But then communism has a tiered system. Japanese society does not.
Oh, okay.
They did have, but then when you conquered them, that
yeah,
stopped.
well, we kind of like stripped their military and everything, and we let them like keep their emperor in like I guess it's like a ceremonial position. He doesn't have like legislative power anymore. No. When you conquered them, Gio, you specifically. Yeah. Yes, when I conquered the Japanese, I was there in spirit. Yeah. Also, yeah, being born in Japan and ethnically Japanese, yeah, that's a whole other thing, I'm sure. That's what do they call it? Gaijin? Or, Gaijin, that's it. Like, Gaijin are like white boys in like Japan.
Nobody says that anymore. I mean, it's like considered to be quite racist, actually.
Oh, is it? Oh.
So they've kind of gone away from that, and now it's Gai Kokujin.
Gai Kokuju. Okay, cool.
Jin.
Gai
Kokujin.
Gai Kokujin. Okay, cool.
So it's
I like Japan.
The difference between outsider, which is the offensive term, and just foreigner in the general sense.
Oh, I see. Kind of like when we say like illegals. Like I feel like at some point calling someone like an illegal is going to be like derogatory. You know, like illegal aliens.
Well, it is for some of these crimes.
Well, I agree. I mean, everyone gets offended by everything at some point.
It's a statement of fact, or it isn't.
I agree. Yeah, I love when they say like there's a difference between like reporting versus like accusing, right? This recent thing with the Wall Street Journal saying that they're reporting that Pam Bondi told Trump that like, yo, bro, your name is all over this fucking Epstein file thing. And like now Trump is mad at the Wall Street Journal for saying this, and he's like not allowing their reporters on Air Force One, blah, blah, blah. And it comes down to the fact that like, and now he's suing the Wall Street Journal for defamation for like $10 billion. It's ridiculous. Because he's saying that what the Wall Street Journal is saying is like accusatory. Like they're accusing Trump of this. And it's like, no, bro, we're not accusing you of anything. We're just reporting. Like this is literally just what the facts are. If it's accusatory, it's because you fucked up. You did something wrong, and now you think you're being accused of it.
I don't know. It must be some kind of attempt to force his hand to release the files.
Yeah,
which he's
I don't know.
To himself for some reason.
I don't know. The House just recessed for the summer, so like nothing's happening till August. So another 4-star, correct? Another 4-star from Blessed Aleph. An inverted pendulum. A pendulum consists of a mass at the end of a massless stick of length L. The other end of the stick is made to oscillate vertically with position given by y is equal to a cosine omega t, where a is much less than L. Okay. It turns out that if omega is large enough, and if the pendulum is nearly upside down, it will not fall over as time goes by. Instead, it will sort of oscillate back and forth around the vertical position. Dude, what? Yeah, good to see you, dude. For sure, Amelia. You're very welcome. Yes, you rock too. Yeah, and Zev, I'll hit you up later tonight if I have time to the game. Definitely tomorrow night, because I'm taking a break after tomorrow night if I write this exam. I don't know. This to me looks like something with a Lagrangian and a Hamiltonian, and then you have to get some equation of motion from it, and then you have to wait, what's going on here? Sorry, what the fuck's the box? And then you have to just like prove like stability, right? You have to prove that it has like a restorative force trying to like keep it over the center of mass, right? There's a critical angle. This is, I'll explain some of the parts of this. Finding out tipping point. I don't think I'm actually gonna solve this one, especially if it took you 3 hours. But this is it. This is what you have to talk about. So it's when the center of mass crosses. Yeah, it's when the restoring torque no longer brings it to its original position, and it starts to actually. You think about this, like if you start like pushing something, eventually it tips enough that it just keeps falling. Physics. Figure out in physics. Yeah. But how do you define it again? What's up, Equity? I saw your questions. I think it's something where the force of gravity and the torque due to gravity and the torque due to the normal force, like, balance. Tipping. Love it. You're welcome, Yanni. I appreciate your support. Yeah, that's what it is. It's when the torque from the center of gravity causes it to like keep tipping over. If it's a restore here, this is what it is. Yeah. So, if something is like being slightly tipped, right, this way, this is the center of gravity, which is like the center of mass of an object. That always points straight down. So in this case, if this is your rotation point, okay, then you still have torque that is now in the clockwise direction, and that's trying to have this thing go back down to its original position, okay? You can have something perfectly balanced where the center of gravity has zero torque, right? And in that case, because the R, so here it is, right? Torque is equal to R cross F. So if R is parallel to F, then torque is equal to 0. So in this case, R always points from your rotation point to where where your force is being acted, which is at the center of gravity. So here, R cross F causes it to rotate this way. You're okay. In this case, R is this way, F is this way. If they're parallel, your torque is 0. So gravity doesn't push this thing either to the left or to the right. But if, for instance, here, Now R is pointing this way. Your force is pointing this way. This is creating a torque in this direction, which is going to continue to cause it to fall. So this is a case, this is where things like tip. So this is like tipping point. So the tipping point is when, yeah, I think what you do is you solve for where torque is equal to 0. That's the stable. And then if you ever have the center of gravity move any bit to the right, in this case, it would continue to fall. If you moved it to the left, it would stabilize itself and balance. So this is the tipping point. So in this question, when they say like there's an inverted pendulum, so mass of stick L, and then they're saying this is oscillating up and down, and they want to know whether this falls over, okay? I think you have to think about how the force of gravity is pulling it down, right? And then what that looks like compared to some like rotation point here. Or actually, let me use the same colors I was using. So this is the force of gravity. And then you have, this is kind of like your R vector. And there must be then some sort of tension from this. Yeah, there's got to be a force from this then. Because if this is moving up and down, then you're going to have a force in this direction, right? So I think what you're doing is you're trying to see where the force of gravity from this balances out with the force of gravity from this. That would keep it from falling down. Yeah, okay. That's length L. And then they say the angle of the pendulum measured to its upside down position. What do you mean is upside down position? Are they talking about this angle? Dun, dun. Okay, and I think you did it. What'd you get? Show me, Aleph. Because what I see is if y of t is equal to a cosine omega t, then y prime of t is equal to a omega, negative a omega sine of t, and then y double prime of t is going to be equal to negative a omega squared cosine of t. So then this right here, this is your acceleration. Wait 10 minutes? Okay. So, and I think that acceleration, you then have to multiply by, what's that going to be? Sine of theta. So, negative a omega squared sine of theta has to be equal to mg, I think. I think this is kind of the crux. But yeah, all right. Keep stabbing at it. I will just for shits while we wait for this one. I'm gonna set loose ChatGPT at it. And just see what it gets.
What the hell is Yanni on about?
Inverted minus blank. Yanni's vibing, dude. Yanni is vibing. Okay. All right. Let me see. Some other people had questions. Good. We got Reki. I got Equity. Equity's first. Equity, are you here, dude? Sir Bob Ross's. Yeah, he is here. Cool. All right, let's do his. Okay, it says a musician released a new song on a streaming service several months later. And then talk. Okay, I see you. Well, I'll get through all your questions today, guys. I will not forget you guys. You just gotta hang around. Number of plays in thousands after T months. Okay. Cool. The total number of plays in thousands for a song since its release can be modeled by the function given by that, which is a quadratic. Okay, cool. Use the given data to write 3 expressions that can be used to find the values for the constants a, b, and c in the expression for d of t. Oh, wow. Okay. So you have some points here, right? You have 0, 25. You have 2, 30. And you have 4, 34. And we're asking if y is equal to ax squared plus bx plus c. What are the constants? Interesting. Yeah, Fembox, this is I'm trying to fit a quadratic. How do you fit a quadratic? Oh, okay, wait a minute. Okay. I know 0, 25, right? This tells me right away that c is equal to 25. Yeah. Well, also I have like an intercept, which is nice, right? So c equals 25. So then we know 30 is equal to a times 2 squared plus b times 2. And then that 34 is equal to, yeah, you're exactly right, 4 squared plus b times 4. That's really cool, actually. And then this is plus 25. Plus 25. Okay. Cool. So 5 equals 4a plus 2b. And then 9 is equal to 16a plus 4b. So multiply by 2. Let's multiply this one by 2. So I get 10 equals 8a plus 4b. 9 equals 16a plus 4b. Subtract the 2, right? That goes away. You get 1 is equal to negative 8a. So a equals negative 1/8. I think that's true. So a equals negative 1/8. And then if you plug that back in, you get 11 is equal to 4b, I guess, right? So if I plug that into here, I get 9 is equal to negative 2 plus 4b. 4b equals 11, b equals 11/4. Cool. And then c is equal to 25. Wow, that's pretty cool. Aleph, what? That's the answer you got? A squared omega squared over 2 minus g over L. Oh, that's cool. That's the angle? G over L. That looks like some omega thing going in there. G over L. That's square root G over L's, yeah. Okay. Average rate of change. Well, this is easy, right? Right? So average rate of change, that's just between this point and this point. So that's just y minus y. So that's 34 minus 25 over 4 minus 0. So that's equal to 9/4. And then they say to do that for 1.5 months. Okay. So then you have an equation. So you have y is equal to 9/4 plus 25. So at 1.5 months, that's y is equal to 9/4 times 3/2 plus 25. So that's, I don't know, something as a decimal, but yeah. Explain in general why A of t is always less than D of t. Yeah. It has to do with the fact that this is a quadratic, okay? Which, wait, why was my A negative? Oh, it's a negative quadratic concave down. Yeah, okay, I guess it's this, right? Yeah. So here, whenever you're measuring the average rate of change, yeah, it's always going to be below the tangent line. Well, it has to be on, like, this side of it going up, though, right? Right. Yeah, anytime you measure the average rate of change, the instantaneous rate of change is bigger. So this is like f prime, and this is like average. Or the thing they call this is like tangent, and this is secant. Cool. The quadratic function has exactly one absolute minimum, one absolute maximum. The minimum or maximum can be determined the domain restriction for D. Well, the absolute minimum is 0, right? You can't sell, you can't have less than 0 plays, so 0. And then the maximum is whatever this vertex is. Yeah. Wait, this kind of doesn't make any sense though, bro. What? So the total number of plays is going to go down eventually? That's not very good. Okay. I guess, yeah, the domain is measured. Oh, sorry, I'm talking about the range. Yeah. So the range has to go from like 0 to the max, which the domain for that is also 0, because you can't have like less time than you've actually released a song. So this is 25. And then you just got to figure out where the max is, which I think is b squared minus 4ac. Is that what it is? Or it's negative b over 2a, I think, right? Is this max equal to negative b over 2a? So that's 11 fourths divided by, or negative 11 fourths over negative 2/8. So that's 88 over 8. Oh, it's equal to 11. Oh, okay. Cool. Yeah, so this goes all the way out to 11. So the domain goes from 0 to 11. That's cool. Okay. Not bad. I think this was probably the hardest part, realizing that it's a system of equations, but does that make sense to you, Equity? Yeah, good stuff. It's a cool question. I like that one. That was fun. Yeah, you're welcome. What's up, Equity? Are you prepping for like calculus coming up next year? Are you just going through random questions? I mean, I'm glad if you are. It's really great. Yeah, sick. Okay. Yeah, just get ready, get prepped, you know. Then it's just like, you can just coast, dude, when you're in school. You can be like, I already know this shit. Or you could be extra and start taking even harder, like, college classes if you wanted to. Okay, Reki, where you at? If not Reki, then Ethan, and then Taco Cat. Okay, Ethan, what's up? You want to come up, do your question? This is Ethan's. Let me tag him. Yo, what's up, Ethan? Thanks for waiting. Yeah, Earth. Science. Yeah, Mr. White, science. Okay. A snooker ball must be 5.175 centimeters in diameter to with an uncertainty of 0.127 millimeters. The Earth is 6,371 kilometers, and its highest mountain above sea level is that, which is smoother. What?
I was just coming back from the restroom.
Okay. I actually don't know. What? Sorry, what is like smoother, dude? What does it mean for something to be smoother?
I would assume like their shape itself, like a curved shape or like their straight shape.
Okay.
I mean, I would assume it's that.
Max height over radius. Oh, that's what they say. Okay, so smoothness. Subtable. So smooth is equal to max height divided by radius. Is that what we say?
Is that
So a snooker ball has 0.127 times 10 to the minus 3. Do I add that? Oh, so it's max height over the surface. Okay. So it's that divided by 5.175 times 10 to the minus 2. So this is for the ball. And then the Earth. That's 8848 divided by 6371 times 10 to the 3. Table says, are you going over random questions or are you down to teach some requested concepts for stats? I'm kind of just doing random questions right now. If you have a specific statistics question, you can submit it using this. That's our website for like submitting. Students just are sending me screenshots and I just go through them. Jeff loves stats. Yeah, Jeff, when are you going to stream, dog? Okay, let me get my calculator out. We need a calculator for this. Okay. So we have.
Is that hard to you?
It's not hard. No. You just have to divide like this stuff. So 0.127 e the minus 3. Also, Jeff, how do you know what smoothness is, dog? What other job do you have that you deal with smoothness? So this is 0.00245. Cool. Now let's do the Earth. Let's do Earth. 8848 divided by... Yes, Reiki, if you're here, I'll do it. This is 0.00138. It's much easier to criticize streams than to stream. Bumpiness. Yeah. Okay, so I think the Earth is smoother. Because this is lower. More smooth.
But just like yesterday, I have the solution if you wanted.
Oh, what's the solution then? Yeah, what is it? Tell me.
Don't worry, I'll send the screenshot in. It's just hold on. It'll just take like a minute.
Okay.
You want it in the same chat, the same Discord chat, the office hours chat?
Yeah. Or just send it in this chat or whatever.
Okay. I was just saying that, like, I'll send it in the chat. Hold on.
Yeah, just send it in this chat.
Should be sent. It should. Yep, it's sent.
All right, let's see what they got.
That's the solution that's on the page.
Ah, look what they do. As smooth as my bald head. That's funny.
Really?
So, yeah, this is what I got. Look, yeah, 0.138 and then 2.45. Nice. The Earth is smoother than the snooker ball. Nice.
This is a plug and chug situation.
Sorry, what's up? What'd you say there, Ethan?
Plug and chug.
Plug and
Like,
chug?
that was just a plug and chug.
Well, it wasn't really like
Is that
plug
it?
and chug. I still had to like figure out that smoothness is like displacement divided by radius. It kind of makes sense. It's like the percent error in the radius. So it's like the plus minus.
But yeah, on
It's
the
like the
other-
delta over the actual. Yeah.
Hello there, but I wanted to say something, and I don't
What do
know
you
if
wanna
you
say?
told the viewers yet, but have you ever? I messaged you about that coder thing, about which email I use.
Yes,
I know
I'll
I used
email
it
you
before,
guys.
but, like,
I don't. I'm now realizing I don't think I collected emails from you guys for summer camp.
Oh.
So
Well, I'm just using my
I think I fucked up.
I can just switch over to my personal email and nothing so bad.
Let me confirm confirm that with you later tonight. Don't worry.
I don't think.
Yeah.
But
You
yeah,
guys will
I
have
can't-
all. You
I
guys will
don't
have all week to do it and all weekend. Yeah, it's okay. Let me. I gotta look through it. I gotta figure it out.
Alright then. And I think so. Wait, I thought last week you never streamed last week's yet on Wednesday. What happened today? Like,
I do
why
stream
are
on
you streaming
Wednesdays.
on
No, I always stream on Wednesdays. What? Yeah. If you're curious about when we stream, we have a calendar, right?
Yeah, I thought I didn't. I don't think. I think I might be wrong, but I do not remember you streaming last week Wednesday.
I
I
did.
don't know.
Yeah, I streamed last Wednesday. Yep, I'm on the calendar. If it's here on the calendar, I streamed.
And like you said something about gaming tomorrow.
No gaming tomorrow. Oh, I'm gonna play games with Zev Hebrew Hammer tomorrow night. Just 'cause that's like a friends thing we do. But Table says, "Bro, I'm sorry. I've been studying for the past few days and I feel cooked." Oh, it's okay. Do you have an exam coming up, Table? What's up? When's your exam, dog? Oh, Sensation's coming after him for the English.
It's like, surely there's a fridge in your house.
Oh my god. Tomorrow. Oh no. Hey, Table, if you have like something on your test review that's like difficult, send a screenshot. I'll do it.
Yeah.
Did you already send it? I think you did. You did, Table. Thank you. Cool. I see it. Let me do one of these kids' quick questions and then like I'll do yours, Table. Just stick around.
And if you don't sort your head out, I'll come to your house and beat you with a dictionary.
Sensation, come get you, dude. Yeah. But this is your question. I see it. This is what it is.
Sorry,
What's up, Ethan? What's up? Yes, Ricky, I'm
Just
doing
one
your
last thing
next.
before we go.
One last thing. What's up?
So since I asked the questions 3 times for this week, I get my full credit then.
You just have to ask
trying
once per
prove-
week. You just have to ask one once per week. You don't have to answer 3. You don't have to ask 3 times. I mean, I appreciate you asking 3, but you just have to ask one.
¿Por qué?
I'll do it.
¿Por qué?
So yeah, I mean, I'm just telling you, like, next week I'll be going back to work already. Like,
Okay.
so most likely when you're streaming, I will not be there. I mean, I could be lurking, hopefully, but I don't
you can
think
lurk,
I'll be able to ask. I'll just lurk, but if I could get a day off on Monday, Tuesday, or Wednesday, then I could still watch the streams and I could still get full credit, right?
Nice. Yes. Correct.
Saturdays I'll always be working in the evening, so if you have a game on Saturday, I will most likely not even show up.
Yeah.
I'll still give it my best effort. I'll still give it my best effort.
Good.
Don't worry.
All right. Here. Good. Yes.
Later.
You do it. You're good.
No.
All right. Let me see. Recky's here. Mira uses algebra to rewrite the function grasp by hand. Okay. What does she do wrong? Okay. I mean, this is kind of a weird flex, but sure. So she does that, and then she does minus 21 plus 21. Okay. Oh, I already see the error. Yeah. Here, this should be a plus. Or... yeah, what she should have done is she should have brought that one over. Yeah, this should have been negative 19. Yeah. You should have pulled the 3 not out of this one. The negative 3 should have been pulled out of this one. Yeah. That's actually kind of a cool way to do it, right? Because then this is negative 19. Nice, okay. minus 3. How might Mira have discovered what she made an error without using technology? Plug in a point. Plug in an X, find a Y. Using technology, she could have graphed it. Yeah, X equals 0 is a great one. Yeah, could have literally just, like, what is the X-intercept? Or the Y-intercept, sorry. Ask AI? No. No. Yeah, use technology. Yeah. You could also graft it. Yeah. Okay, cool. All right. That's a cool question. Good job, Rex.
Well done! Well done!
Okay. I eventually got Taco and Nick. I'll do some of yours, but let me help out our new friend here, Table. Mir should have stopped by Actual Education on twitch.tv. Correct. Okay, here we go. All right, I'm going to ignore all this stuff because whatever. Okay, here we go. Hydrogen content in different soil samples are required for optimal crop growth. The more the better. 3 possible sites were chosen and 5 were landed for each site. Nice. Thank you, Yanni, dude. You're welcome, Murky. Some of the data is corrupted, which is a question mark. Interpolate the missing data and test the hypothesis that some sites are more optimal than others for crop growth. The mean hydrogen content across all 3 zones is 16. Okay. So, this is a fun yeah, right? So, we are going to do an ANOVA test. An ANOVA test is... so, you have the null hypothesis, which is that, like, mu1 equals mu2 equals mu3, right? You're saying that I think that the mean here is equal to the mean here, which is equal to the mean here. We don't need ANOVA? Okay, maybe we don't. Just averages? Okay. HA says that mu1 is, like, either not equal to mu2, or, like, mu1 is not equal to mu3, or mu2 is not equal to mu3. Exactly. So, I think testing the hypothesis, I think we're eventually going to need an ANOVA, right? But we can get this. So, if we know the total mean here, right, is 16, then this stuff has to have a mean of 16. So that means that x plus 16.6 plus 15.8 all over 3 has to equal to 16. There's no hypothesis? What do you mean? Yeah, there's always a hypothesis. In stats, it's the null hypothesis. This is the hypothesis we're testing. It's that one of the means is better or not equal to the other one. Yeah, uh-oh. It's okay, Jeff. Where's Table? Is Table watching us? I hope Table's watching us. There you are, Table. I'm just going to tag him. Okay, so we can figure this out. Is that a grand mean formula? I have failed you. Well, no, I think this is easy. Watch. So 3 times 16 is 48. So 48. And then we do minus 15.8 minus 16.6. Right, so that gets me the missing mean as 15.6. So here we get that x is equal to 15.6. Yeah, this is just the mean. This is just the grand mean. I guess is that what they call the grand mean? I guess it is the grand mean. They said the mean hydrogen content across all 3 zones is 16. So that means, and because you have the same number of probes, right? They're weighted the same. So it's the average mean. Yeah, it's the mean. So you're averaging all 3 of these to be 16. And so this is going to, the mean of Flegra dorsa is going to be 15.6. Does that make sense, table? Yeah, but I'm more like I would be easier to visualize with a formula. So this is the formula. This is the formula for mean. So when they say the mean of all 3 zones, the mean hydrogen content across all 3 zones, right? You're okay for your English. It's okay, dog. So that's the sum of all of the data points. Let me think how I want to do this. Here, let me call Flegra dorsa A. Let me call this B. Let me call this C. Okay. So if I wanted the mean of everything here, right? I would sum up all the individual things in A plus all the things in B plus all the items in C. And then I would divide it by the number in A, the number in B, and the numbers in C, right? This would be the, like, I guess the grand mean. And I know this has to equal to 16. Okay. What I know though, right, is that kind of makes sense, yeah? Okay. This is also the same thing, right? I can separate this out as the sum AI over NA plus NB plus NC. The denominator 15? Correct. Yeah, it would make the denominator 15. So, yeah, one sec. Before I do this, NA plus NA equals NB equals NC is equal to 5. So now you have the sum AI plus the sum BI plus the sum of CI all over 15 is equal to 16. Okay. These numbers here, right? This number right here. This is the same thing as the sum of BI divided by BN or NB. Okay, which is BI over 5. And then this right here is the sum of CI over 5, right? So now I have some cool things here. Because what I'm going to do is I'm going to divide the whole top by 5, and I'm going to divide the bottom by 5, and watch what happens here. So I'm going to go, okay, cool. Let's do divide by 5, divide by 5, divide by 5, divide by 5. As long as what you do to the top, you do to everything, and what you do to the bottom is the same, that's legal in math, okay? So now this gets me sum AI over 5 plus sum BI over 5. But sum BI over 5, right? That's equal to 16.6. And then the other one here is 15.8. And then this is all over 3. And this is equal to 16. And then this thing right here is what this is. Yes, 16, not 6. Thank you, Jeff. Okay. Do you see, like, what we're doing here is really the same as what we did here? We just added the 3 means and then divided by 3 and then said that had to also equal 16. This is kind of like, I guess, a proof of where that comes from. Make sense, table? Okay, cool. Okay, so let me put this on a new page because I just need new things here. Okay, so I know this is equal to 16. And now I gotta find some things. So I gotta find this missing value here, okay? Well, I know if I add all these up, right? 19 plus 15 plus x, thing I don't know. Let's call this like x for now. Plus 17 plus 14. That all divided by 5 has to equal 16, right? This is the mean of, again, let's say this is A, this is B, this is C. This is like A bar, right? The mean of A is adding up all these data points and dividing by 5. So on a calculator, that's 19 plus 15 plus 17 plus 14. Oh, sorry, is it not 16? Sorry, what did I say it was? 15.6. Sorry, I fucked up. Thank you.
That's dope.
I fucked up. Sorry. I got a little fucked up. Thank you. 15.6. Thank you. Okay. 19, 15, 17, 14 equals that. Okay. And then we're going to do 5 times 15.6. And then we're going to subtract your progress. Ooh, have you been doing Legos? That's cool. We're going to subtract 65. Cool, you get x equals 13. This is algebra you just have to do here, table. So x equals 13, all right? So now this thing here is going to be 13. You do a similar process for this one. Wow. What's up, Merryweather? What's up, my homeboy? My Hagmaxer, dude. Let's call this like why. Appreciate the follows, everybody. Love you. We're doing some stats right now. Table has an exam tomorrow, and he's freaking out. We're gonna allay his fears. Very late follower. Yeah. Xmidio's been here before. Yeah, it's okay. Okay, so we can solve for y here then. Alright, and then that's going to be 18 plus 14 plus 16 plus 17. Then 16.6 times 5 minus the 65. You get y is equal to 18. Okay, so this is equal to 18. Nice.
Good job.
Good so far, table? Yeah? We rocking and rolling? Oh, this is sick. It's Formula 1 car. Technics, sick. Dude, now you have to compute standard deviation, which is honestly a bitch. To do by hand, this is so bad. Do you have to do it by hand, table, or can we just use like a calculator? You gotta do it by hand? Ew. Okay. Yeah, I will do one of them by hand. I'm not gonna do both of them by hand. It's gonna take too much time. So here, if we want to calculate this standard deviation, let's like pull this down. This is 15.6, and then this is This is 13. Okay. The way to calculate standard deviation is you take the sum of x minus xi, or sorry, xi minus x bar squared. Wow, thanks for the sub, dude. Look at that, he followed and subscribed, dude. Some people think you should use absolute value instead of squared. I don't think so. Oh, because I think you square root all this, right? Isn't the standard deviation squared is equal to the sum of this? And then it's over n minus 1. Yeah. Yeah, this is variance. Yeah, so this is technically variance. So you do 19 minus 15.6 squared plus 15 minus 15.6 squared plus 13 minus 15.6 squared plus 17 minus 15.6 squared plus 14 minus 15.6 squared. And then you do all of that divided by n minus 1, so that's divided by 5 minus 1. There's a controversy to this? What's the controversy? Oh. Well, I already see a difference with the 1 over the square root of n over there, right? Yeah, I mean, it just kind of sucks to do this by hand, table. Do you get a TI-84? Like, because I can just show you how to do this in a TI-84. This is so easy. You just go to edit here, and you just make a list. So 19, 15, 13, 17, 14, right? Then you just do stats, and then you just do fucking one variable stats on this bitch, and then L1, cool, calculate, and it'll just do it. So there you go. So there's your standard deviation. You have an FX911ES? That might have it too. But yeah, you just get all this information, which is great. So sigma x squared. So if you were to... I gotta remember which one. Which one do you want? Sampler or what is it? Sample? I think you want sample standard deviation, which is the S1. Yeah, because that's the n minus 1, because you're dealing with a sample. So in this case, you want to use the SX. So that's going to be 2.41. Just trust me that that's what the math would come out to be. 2.41 here. And here's the cool thing. You can just go back in and here, we can put the other numbers in, right? 18. What was this other number we had? 18, 18. Okay, cool. 18, 14, 16, 17. And then you have 14, 16, 17, 15, 17. And so if you go do one variable stats on, for instance, L2 here, do you see how we get the same 1.67? So that tells us that's the one we want, the SX one. So then if you did one variable stats on L3, that gets you the 1.3. Cool. So there you go. That's all the means and standard deviations. So the last thing is the hypothesis test. Okay. I need to remember. What is it? FX991ES? I mean, you may have some stats on it. Apparently it can do... Dude, if it can integrate, there's no way it can't do statistics. Maybe it can't do statistics. Damn. Well, that's annoying. No. I was hoping you could... Yeah, you can't do it. Oh, it's this one? This is the one you have? Yeah, I don't think this has stats on it, unfortunately. Okay. Well, this is the math way to do it by hand. I'm just putting in the numbers. Try to do it yourself and see if you get the right answer. But that's the right equation. And this is SD squared. So then to get SD, you have to do the square root of all of this to get standard deviation. Okay. I gotta remember how to do the test for this one. Let me grab it. Where did I grab it here? No, where did I put it? I'm just gonna ask ChatGPT. I think it's an ANOVA test. What test do I need for this hypothesis? Ignore. I agree that they overlap pretty easily. I want to know why that is, though. Right, so null hypothesis, as I said, they're all equal to. Alternative hypothesis, at least one is different. We said that. That's what this was. Okay. Yeah, but I think I actually want to run the ANOVA test. Or, yeah, you can just say that there's a lot of overlap, right? One standard deviation is only 66%. So, yeah, there's a lot of overlap. Let's see if you can do it on here. I don't know. How do you run a... Here, let me see. Like, how would you run an ANOVA test by hand with 3 sample groups, means, and standard deviations? Okay, so you compute the grand mean, which we already know that, right? Grand mean's what we computed. That was 16. You gotta do SSB. Okay. SSW. And then you have to use these degree of freedoms, and then you have to calculate an F statistic, and then you compare it to a p-value. Okay. Yeah, for sure. How a p-value works. Yeah, okay. So you'll p-value is like the percent chance of you like making a mistake. Right, exactly. Yeah. It's the percent chance that that your result is just coincidence versus it being actually statistically significant. So if that percentage is low, right? If p is like 2%, like 0.02, 0.03, that means there's only a 3% or 2%, whatever chance that these differences are due to random variation. How do you figure it out? So, by hand, you have to use an F table. So what you have to do is you have to get this F statistic, and then you have to use an F table where you look at the degrees of freedom between the groups, which is DFB, and the degrees of freedom within the groups, which is DFW, and then you have to look it up. So for instance, F table, this is what you need. You need one of these. So what I really like to do is to calculate F critical. So here, let's do this. They're related, but they're not the same. Okay, so for instance, if we looked at our data here, and here I'm just going to calculate what the value is. So let's go to stats, test. I'm pretty sure there's an ANOVA test here. Here, ANOVA, and then it's like L1, comma, L2, comma, L3. I think you can just do this. There we go. Okay, so this gets me an F of 0.4 and a P of 0.67. Wow. That's huge. Right? So, yeah. F is equal to 0.4. That is so low, it's not even on the table here. Yeah, you need a high F for a low P. So, for instance, this is for P is equal to 0.05, and this is what the cutoffs are. So, depending on, like, how many groups you have, and then how many things are in the group. So, in this case, DF1, and I forget, is it -1? Yeah, between the groups... Yes, okay. That's going to be equal to 2. So you have 2 degrees of freedom on the top, because you have 3 groups, and 3 minus 1 is that? Okay. And then I think degrees of freedom, DF2, that's n minus k. So that's 5 minus 2, so that's 3. So this is the number. So F equals 9.5 is the critical F for P is less than 0.05. So in order for there to be a difference, you need an F value. In order for there to be a significant difference at what we call like 95% confidence, or we say like alpha is equal to 0.05, you need to have an F value of above 9.5. The F value we calculated is 0.4. So that's very low. So that means that there is no difference. So here's what you can say. You can say F is less than F critical. So fail to reject H naught. H naught is always saying that like there is no difference. There's no change. And you fail to reject that. You can never accept the null hypothesis, by the way, too. It's always like, I failed to prove that they're different. And that's because F is much less, so this is 0.4, is much less than 9.5. And this you have to get from the table. Cool? Does that help you out a little bit? Table 650? Feel a little bit better? Yeah, cool. Nice. Great. Glad to help. You're welcome, dude. Now, if you had more data, you'd have smaller... Yes, exactly, and you might be able to get a significant difference. Correct. Yeah. Yeah. Feel free to lurk. I have to go teach another student pretty soon here, so I won't be able to stream forever. So maybe another 10, 20 minutes. But if you ever want to figure out when we're streaming, there's a calendar there. Feel free to come hop on by, like, subscribe, whatever, follow our thing so we can help you out later. Yeah. Okay, where's Taco? Not table. No, sorry, wrong thing. Wrong message. My bad. Where's Taco Cat? Taco Cat, where you at? If not, Nick, what's up? What's going on with Nick? Nick's playing with his Formula 1 cars. What are you doing here, Nick? Oh, that looks pretty cool. This is the car you're building? Yeah, it looks like an axle. Where'd you get all these Legos, dude? What? Oh, dude, I love this, dude. He's watching the stream right there while he builds Legos. That's pretty sick. Nice. Looks fun. All right, what's up, Nick? Let's do a couple, and then I gotta go teach another student. So much teaching today. Let's see. Let's do these. Okay, suppose that police expenses in a city in a certain year amounted to 7.5% of the total expenses. There you are, Taco Cat. All right. Hang around, Taco. I'll do yours after this. I'm going to help out Nick first.
Can you hear me?
I can hear you, dude. Yeah, you're good.
Oh, good.
In indicating this percentage on a pie chart, which is 360, the size of the angle would be nearly what? Oh, okay.
You have to switch. Yeah.
Got it. Okay. So 7.5% of the full 360 degrees. Okay, right? Right, because this goes around full 360.
Mm-hmm.
And so we need this to be... How do you figure this out? How do you figure out what degrees this is?
I forgot.
So this is really just 7.5% of 360. Do you know how to take the percentage of 360?
Yeah, you multiply it by the...
You move this to the left 2 places to make it a decimal. So
yeah,
that's 0.0075. Good. Times 360.
No, isn't it 0.075? Not 2 zeros?
Oh, you're right. I fucked up. Thank you.
Mm-hmm.
Good catch. Right.
Oh.
And that gets you 27. Okay, yeah. So it's just a single zero.
Mm-hmm.
Nice. Okay. And it's just 27. Sick. That was correct.
Cool.
Okay. Suppose that in a police precinct A, where there are 4,180 children, 627 children entered a contest sponsored by the Police Community Relations Bureau. In precinct B, where there were 784,009, the total percentage of all children in both precincts. Okay. It's just a percentage thing, right?
Mhm.
So you're going to do the 627 from A plus the 1960 from B all over the total population of A plus the total population of B. Okay. This is also kind of like the grand mean.
You
Dr.
have
Phil's on late
to.
tonight. I am. What's up? Let me give Zach a shout out. I haven't given Zach a shout out today. My bad, Zach.
You have to add them both together. You can't do them individually.
Yeah, no, because you need the total average. Yeah, because they have different sizes, you can't do the average of this plus the average of this. You can't like average these two because they're weighted differently. Like there's more people in this one than there are in this one.
Okay.
Yeah. So you have to add them all up as like a super group. Where you have.
Oh, okay. Okay.
Right.
Mm-hmm.
And that gets us 21.5%. Cool. Sick. That's this one as well.
Nice.
Nice. Okay. Good job, man.
Can we do at least one more?
Yeah, we can do one more. Those were easy.
Thank you.
Yeah, let's do this one. The police force ratios. Can we do a partial differential equation? I have to end the stream pretty soon, Camillo. But I will be streaming later. Not today. But also we have other awesome math people that stream stuff. So here, let me make sure I get you the link to this. Also, you can, yeah, if you join our Discord, going to this website, you can post your question there and I can like do it on the side or during the next stream. Okay. Nick, all right. Suppose in 1844, the city had a population of 550K and a police force of 200, 8 million, and that if the ratio of the police... Oh, what is the relationship between the ratios? So it's like, what's the ratio of the ratios? It's kind of funny. All right. So I think it's like... And they're saying 82 to 1844. So the 1982 ratio... That's equal to 32,000 over 8 million. And then the 1844 ratio, that's equal to 200 over 550,000. So then if you want the ratio of them to each other, you do this divided by this. Okay. So that's going to be 32, 1, 2, 3 divided by 8, 1, 2, 3, 4, 5, 6. 0.004. And then we're going to divide that by 200 over 550, 1, 2, 3. And that gets us 11. Okay, cool. So that equals 11, which is the same thing as 11 to 1. Which that's why it's trusty. Cool.
Well, you got it right away. What?
Yeah, I know. I'm really smart.
I'm gonna try to find out the. I had 2 answers for them somehow.
Okay. Well, you'll have 2 different ratios. You would have the ratio for the 1982. You'd have the ratio of the 1844, but then you need to divide the ratios to get like the overall ratio. Yeah.
I'm trying to.
Okay. Let me do Taco Cat. Last one. You better not give me something stupid hard, Taco. Okay. Given lines M and N are parallel, line T is a transversal intersecting M at point A. Okay. line M. Line N. Line T. Oh, this is cool. At point A. And N at point B. Point C lies on T. Okay. Point C lies on T.
This is what I was talking about.
Oh, okay. Yeah. CAB. I don't really understand this. If C lies on line T, then CAB is just this. Where is C though? Do you see how this doesn't make sense though? Like for point C to be on, am I stupid? Am I not just not seeing something? Usually I would think like we do this, and then we find like this angle versus this angle or something.
You done messed up, Aaron!
Yeah, it is a poorly written question. Wait, who wrote this question? Where did you get this question from? Google. Okay. Let's pretend that this angle is equal to 3x plus 15. And let's pretend that this angle is equal to 5x minus 9. What's up, Manor C? That's a cool name, dude. If these are parallel, then this is what are called corresponding angles. So 5x minus 9 should equal 3x plus 15. So then 2x is equal to 24. X equals 2. Did I do that right? Sorry. Yeah, 12, not 2. So it's 36. It's 51 degrees, and this is also 51 degrees. Nice, nice. Whatever. I'll count it. I'll count it. Taco Cat. It was written weird, but yeah. Try to get a question from something that's not just Google, but it's okay. What is this? Nick, what are these screenshots, by the way? What the hell is this stuff? Thanks. I actually seen one of your live streams before, and when I was scrolling up, you popped up. That's cool. Bless the algorithm. It's okay, Taco Cat. I'll count it. We'll do a different one next time. I gotta run. I gotta teach another student. Okay, cool. Awesome. Let's close out the stream. Thank you everyone for coming to office hours. Appreciate all the questions we had today. A lot of fun. Our next stream for tutoring help will be on Monday. That's gonna be at 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, 6 p.m. Eastern. So come on by. You really appreciate these videos? Awesome. I'm glad. I need to make more tutorial videos. I'm gonna start doing that once the school year starts. I've been kind of laxing on it over the summer break because no one really looks up like math tutorial videos. The engagement like goes to shit. But I've been doing a lot of live streams to just help out kids with summer school and stuff. So yeah. All right, nice. Let's go raid somebody. I do have background in linear algebra. I can totally help in linear algebra. Yeah. Also, we have a whole other collection of other math streamers that do things. That's some of their Twitches, some of their Twitch handles and stuff. Why don't you film them right now but post them later? Because people really only look at short form videos. Equity. Yeah, I'm talking about like my quick tutorial videos, which I put like a decent amount of time in. Penn Center did a class on linear algebra. That is true. Yeah. Thanks, Mandercy. I appreciate it. Yeah. If you want to check out, join our Discord or something. It's discord.gg/actual.edu. And there. That's our Discord as well. Okay. Cool. All right, let's go raid somebody. I got a couple minutes before I got to go tutor somebody else. Who's on? Whack'em Wednesday. Oh, I love these people. Cognitive Neuroscience and Star Fox. Yeah, let's go say hi to these guys. I love them. They're always so fun. Go check out our friends, Ask a Scientist Gaming. They play video games and they interview like really cool people in different like fields and stuff. So have a wonderful rest of the weekend. We'll see you on Monday. Peace.